Okay, hello everyone. Simplifying algebraic expressions involving exponents. Example 1. Evaluate, express answers in rational form with positive exponents. So as you can see here, the exponent a half is on the outside of the bracket. It needs to be brought into the brackets using the power rule. That becomes 9 to the half and times p to the negative 2 over 2. The denominator remains unchanged, 6p squared. Then 9 to the half can be converted into a radical, which becomes the square root of 9, and p to the negative 2 over 2 becomes p to the negative 1. Then we could deal with the square root of 9, which is 3, and then we can reduce 3 over 6 to become 1 over 2, and then we could divide p to the negative 1 by p squared, which becomes p to the negative 1 minus 2, which further simplifies to a half times p to the negative 3. We could bring that negative 3 exponent into the denominator and make it positive, which will leave us with 1 over 2 p cubed, all simplified. And then when we evaluate the expression in rational form with positive exponents, as the example asked for, evaluate, express answers in rational form with positive exponents. So 1 over 2 p cubed is a simplified algebraic expression in rational form with positive exponents. Then when we evaluate p equals 3, it becomes 1 over 2 times 3 cubed. 3 cubed is 27, and 2 times 27 is 54. So our evaluated answer becomes 1 over 54. And our simplified rational form with positive exponents expressions is simplified rational form with positive exponents expression becomes 1 over 2 p cubed. And I'll zoom out and we can see the whole process there. Example 1. Okay, let's continue with example 2. And same instructions. We want to evaluate, we want to express this algebraic expression in simplified rational form with positive exponents. So let's begin. 81 times x to the 4 times y to the 6, all in brackets, the exponent half. So we can distribute using power to a power rule, or we could deal with this in radical form. Well, let's keep it in exponential form, and let's bring in that exponent of a half using the power rule, which will allow us to simplify further. So the numerator becomes 81 to the half, then x to the exponent 4 times a half, which is 4 over 2, and then y to the exponent 6 times a half, which becomes 6 over 2, and the numerator's bracket is simplified. The denominator has an 8 on the outside, so we leave it there. Then we could distribute in that 1/3 using the power to a power rule, so it becomes x to the 9 times a third, and y to the 3 times a third. So now we've simplified the numerator brackets and the denominator brackets using the exponent rules of power to a power. So each exponent receives that exponent a half, and in the denominator as well. So each exponent of 9, so x to the 9 is raised to the 1/3, and y to the 3 is raised to the 1/3. That's called the power to a power rule, and you multiply the exponents. Okay, so let's continue simplifying. 81 to the half is the square root of 81, and that becomes 9. But I'll first write it, the square root of 81. X to the 4 over 2 can be reduced to x squared. Y to the 6 over 2 can be reduced to y cubed. All over 8 remains. x to the 9 over 3 can be reduced, and y to the 3 over 3 can be reduced. Okay, let's continue. Square root of 81 is 9. X squared divided by x cubed is x to the negative 1 if we leave it in the numerator. And x cubed divided by x squared divided by x cubed becomes x to the negative 1. And y cubed divided by y to the 1 becomes y squared all over 8. They want us to leave this simplified in rational form with positive exponents. So the 9 over 8 is reduced. The x to the negative 1 gets brought to the denominator, so it's positive. And the y squared stays in the numerator. So we have a simplified algebraic expression in rational form with positive exponents. And now let's evaluate x is 10 and y is 5. X is 10 and y is 5. So x is 10 and y is 5. So this becomes 9 times 25 all over 8 times 10, which is 80. And 9 times 5, well 9 times 25. Well, 4 times 25 is 100. So 8 times 25 is 200, and there's an extra 25. So this is 225 over 80. And then we could reduce. Maybe we can divide by 5, and the numerator will become 100 divided by 5 is 20, so 200 is 40, and 25 divided by 5 is 5, so I believe it's 45. And 80 divided by 5, I believe, is 16. It goes into 8 once, drop to 3, it goes into 36 times, so 16. So 45 over 16. Factors of 16 are 1, 2, 4, 8, and 16, which don't divide 45. So this is simplified. 45 over 16 is the evaluated answer, and 9 over 8, 9y squared over 8x1 is the simplified algebraic expression in rational form with positive exponents. Okay, and finally, example 3. Example 3. Evaluate, express answers in rational form with positive exponents, and we have our third example here. So let's begin. Let's change the color up, and we have a negative 3 exponent on that bracket, so let's distribute it in. It becomes, actually let's turn it to a positive exponent and then distribute it. So it's going to be 1 over negative 2 cubed, and then a squared all cubed, which becomes a to the 6, and b to the 1 cubed, which becomes b to the 3. And then we have the square root of 25, which is 5, the square root of a to the 4, which is a squared, and the square root of b to the 6, which is b cubed. So let's think about that for a second. 5 times 5 is 25. A squared times a squared is a to the 4th, and b cubed times b cubed is b to the 6th. So we have the correct square root of that expression. That's all in the radicand. The entire contents under the square root symbol is called the radicand, and that square rooted becomes 5a squared b cubed. Okay, so we dealt with the negative 3 exponent, we dealt with the radical. Let's continue to simplify. Our next order of business here is dealing with the negative 2 cubed, which becomes negative 2 times negative 2, which is 4, and 4 times negative 2 is negative 8. So negative 2 cubed is negative 8. The 5 remains in the numerator. 1 times 5 remains 5, and a squared and b cubed times 1 remains a squared b cubed, so effectively the bracket's removed. And we have a to the 2 divided by a to the 6, which becomes a to the negative 4 when we subtract the exponents. And b to the 3 divided by b to the 3 becomes b to the 0 when we subtract the exponents. And if we simplify further, the 5 remains in the numerator, the negative 8 remains in the denominator, a to the negative 4 gets moved down to the denominator and it's a positive exponent, and b to the 0 becomes 1, and 5 times 1 remains as 5. So we have a simplified algebraic expression in rational form with powers that have positive exponents. And now we can evaluate. We simplified with only one variable of a, so the b variable divided out and became 1, so we don't have to sub in b equals 2. That's the nice part of simplifying first before you evaluate. You reduce the rational form and part of the factors divide out. In this case, the b cubed divides out. So we just need to sub in a equals 1 to evaluate. And let's continue. So 5 over negative 8 times a to the 4, which is 1 to the 4. And 1 to the exponent 4 is 1. So we're left with 5 over negative 8. And it's always a good idea to move the negative to the numerator. So negative 5 over 8 is the evaluated answer. And 5 over negative 8a to the 4, or negative 5 over positive 8 to the 4 is our simplified rational expression. And that concludes today's video. Thank you for watching. Have a great day. Have a great night. You guys are awesome.